Hello everyone. This video is a short introduction to Kubernetes operators and operator framework, as well as a demonstration of how operator development can be super easy with the best kube native IDE Eclipse. So this demo will focus on a simple demo operator that brings up an Nginx pod and creates a service. And then we'll see some magic from Eclipse side using magic URL and a magic dev file that holds the definition of an Eclipse cloud workspace. Now let's go ahead to instructions on how to deploy an operator and go on the terminal and create a service account, role and role binding. And then we'll actually create the operator deployment itself. Go back to OpenShift and you can see that the pod is there and running, and it's not doing anything. So that the operator has started and it's watching this namespace for a custom resource called app service, but none is there yet. So what I'm going to do is I will create a custom resource. Go back to operator logs and you can see that the operator is creating a new pod, it's creating a new service and reconciling. Now if we go to pods, you can see there is a new pod, example app service pod. And there is a service that exposes port 80. So far so good, but what if I want to start developing this operator and how Eclipse can help here? I have deployed Eclipse in a separate namespace, and let's click the route and you can see the dashboard in here. You can start creating your workspaces from a ready-to-use templates, but as promised, there should be some magic in here, and I will use a dev file that resides in this repository. And a dev file actually holds the definition of your cloud workspace and its components. Let me copy the link to the dev file and construct this URL. So we'll actually call the factory API of Eclipse with a link to the dev file. And you can see that the workspace has been initialized, and while Eclipse is constructing the Kubernetes deployment, let's take a look at the dev file itself, which consists of the projects. So basically I'm telling Eclipse which project I need to git clone and check out and to what location. Then there are components where I request a editor, which is an IDE, and in this case it is Eclipse Thea. And then there is a set of plugins. Exec plugin to provide commands in terminal. Kubernetes plugin is actually a Visual Studio Code Kubernetes extension that runs as a sidecar. Same concerns the Go plugin, since the operator is written in Golang. I will need this plugin. I will need some more RAM to do the compilation. I have a bunch of YAML files, so I will need a YAML plugin as well. And I will have my own image with my own development tools that I need for this particular project. And it's this image, and it contains Golang and Builder, which we'll use to create a container and push it to a registry. And there are commands that are executed in different components, and these commands are instructions on how to run, debug, compile, and configure your particular project. All right, so let's get back to the ID in here, and you can see that My operator source code is right here. I can go to the controller, open the controller. What happened when the workspace has started, Eclipse has created a new deployment based on your dev file definition. And this particular pod consists of 6 containers. It's my developer application runtime, exec plugin, Thea IDE, so a web-based IDE, Kubernetes tooling, plugin Go, and this image is used for YAML plugin. So right now, my IDE is attached to a Kubernetes environment that I need to start developing my project. All right, let's take a look at the app service controller. And the reconcile function is the main thing in here. It basically runs all the time and reconciles resources with the state of your custom resource. So in my case, this is called instance. This is app service. You can see I can navigate through code. I can use auto completion, there are hovers, and all sorts of Golang language support. Let's take a look at what the operator is doing. First thing, we define a new pod. Quite a simple definition, name, image, and some meta information. And there is a function that creates a pod. And same thing for service. A new service is defined and a new service is created, right? So what we can do is we can start debugging. What I'll do is I will run a task that will configure Kubernetes plugin with the right kube config. All right, good. So I've got my namespaces. I will use this namespace by default. And go to deploy, CRDs, and custom resource. And run Kubernetes apply command. And now we can launch the debugger. So we have hit a breakpoint in here, and the operator has already created a new pod. We can actually go and check a few seconds ago, right? But there is still no service. Yeah. And let's step over. So we now have the definition of a new service, and we'll call a function to create this new service. And the error is nil, so everything is okay. We can stop the debugger, go back, and you can see that the example app service is there. Let's actually go to any pod in the cluster that has curl in it and check if it actually works. So the Nginx replies to us, everything's fine. Good. Now what I can do is go ahead and uncomment this piece of code, which actually creates a new route and updates custom resource with the URL. Right, so now if I go to custom resources, app services, there is no status field in there, right? But there will be now. I have saved the file, and let's run a task. I have a command that builds a binary. All right, you can see that the binary is being compiled at the moment. And there will be multiple ways of launching it. One way is to use a command, which is predefined, and another way is an all good way of going to the terminal and actually executing the operator binary. The compilation will take up to a minute in this case, I think. And once done, we'll have a binary right here in build subdirectory. So demo operator is in there. So let's open a terminal and go to build. Export watch namespace equals che and demo operator. All right. So what's happening, you can see that the updated operator is creating a new route. Cool, let's go ahead and check it. Applications, routes. There you go. Cool. Now, if I delete that route, it will be recreated because, as I've previously told you, the reconciler is running all the time. Okay, now let's stop it. And there is one more commented line in here. Is actually, why don't I take a look at what's in custom resource spec? Maybe I can read it and extract some information in there. There is a field, route name, and I can actually use it. Let's do that. Back to controller, and here instead of using route name that equals custom resource name, I will use a value from a spec. And also what I'll have to change is to delete this line and uncomment this one. So since my custom resource is already updated with the status containing the old URL, right? Example app service. But what we have here in spec is route name should be demo route, right? Okay, let's build it again. Oops, wrong command. Sorry about that. Task, run task, compile binary. There you go. So we'll recompile and rerun. Creating a new route. So now I expect to see two routes. That's right, demo route. Yep, it works. And now what's more important is that the app service status should have been updated as well. There you go. It's demo route. So this way you can teach your operator to react to changes in the custom resource spec or Kubernetes events or any other conditions to do certain things to manage to maintain your web application. So this inner loop can never end as long as you have energy and stamina to write code, to debug, to fix bugs, to introduce new bugs. But let's not forget that we have originally started with the operator namespace, and my operator is still running the old version in here. While it's okay to check that everything works in your developer sandbox, which is an Eclipse Che workspace, of course, it's better to check whether or not your changes do not break the actual deployment. So what I'll do is I will run a task that will build a container image using builder. It's using the same Docker file that the original deployment, but I'm adding the binary that I have built during my development journey in an Eclipse Che namespace. Right, the image is built, and now let's run the last task for today that will push this container image to an internal container registry in Minishift. But that can be any container registry of your choice, a public one running in your intranet, etc. All right, the image is there, and what I can do is actually go to operator deployment YAML, and you can see that the YAML plugin has some warning for me. Yeah, my deployment does not have any resource limits, so this operator can eat all the memory in your cluster. Not good. But that's not the point. The point here is I will update the deployment YAML with the new image, and I will go to namespaces, find my operator namespace. I will use it, and then I will do Kubernetes apply and click apply. So right away the deployment is being updated, the old container is terminated, and a new one will show up. And this one will create a new route and update the app service status with it. Let's check routes here. So we have it right. And when taking a look at custom resources, the right status is in there. So basically you can continue the inner and outer loop as long as you need to. And you can share this magic URL with the dev file as a say as a button here in README file, so that everyone clicking on that button will be provisioned with an Eclipse Che workspace that runs on Kubernetes, that has all of the tooling that a developer will need to contribute to your operator. Thanks for watching, and let us know what you think.